General Networking, Network Fundamentals. We're going to talk about network topologies, components, and devices that we can find in our networks. Let's start with network topologies. We have many different topologies that we can find in our networks today. On the screen you can see the most popular ones that we have had in the last 20 years. Today, the most popular one that you can find is a star topology. That is here. It's something that we use everywhere, and not even sure if you're watching my video now, you're watching it online or watching it on your PC, you are probably using a star topology. What do we mean by that? As you can see on the screen, we're talking about this topology, star. The idea is that you will have one central device. In most cases, it is a switch. Of course, you can say, well, do I have a switch at home? Sometimes you will have a switch, a router that is a switch as well. What do we mean by that? Let me show you that straight away. We'll talk about it later on. Here, that's what you have at home. That's a router. It has a built-in switch. Let's go back to our topologies. The star topology is the most popular one. Again, it has a central switch, computer, hub, and this device allows all other devices that are connected to your network to communicate, to exchange information, to send data, and so on. There are a lot of advantages if we talk about the star topology. First of all, it's performance. When we have a star topology like that over here, it means that this PC here can send some information to this guy can talk to that guy. What will happen if this device dies tomorrow? That's not a big problem. This guy can talk to that device. Of course, we cannot send anything to this PC anymore. Nothing else has been affected in our network. That's a great thing. Of course, that's what the advantage of a central device is. It's capacity, isolation, performance, no disruption to our network. When we want to remove a device, let's say you want to take this PC and connect it over here. This guy and that guy, they will not be affected. It's pretty easy to add new devices, to remove old PCs, laptops, printers, move them around. It's not a big problem. Okay, do we have any problems with that? Well, of course, there are always disadvantages. The problem is that if this guy dies, everything will be offline. That's the main problem. It's not very expensive today. That could be a disadvantage many years ago, when a switch or a hub, they were very expensive. That's not the case, especially a switch. That's not the case anymore. Today you can buy a switch for, I don't know, £5. A brand new switch, £5. A router, £20, and you can have a star topology at home. Another problem with a topology like that might be cabling. When you think about the star topology, again, you have a switch, and then you have all devices connected. You have to run a cable here. If you want to move a device, then you have to rerun a cable. This problem applies to many solutions and topologies. something that you have to remember and check if you want to move this PC to the second floor or to an office next door. Make sure that you have a socket on the wall or a way to patch to connect this PC to your network. When I talk about network designs, I cannot forget about access, distribution, and core layers. This is described by Cisco. It is followed by many other vendors, and most networks look like that. I will show you a building in a moment and how you can design a network like that, and I will show you a home network as well. Generally speaking, we have three main layers. The first one is the access layer. What do we mean by that? This layer is responsible, it's pretty easy. You connect end devices to it. Laptops, PCs, printers, scanners, everything that you can imagine. Not a very sophisticated role at this layer. These are in most cases switches, and they are responsible for connectivity, connect end devices to your network. Then we go to the distribution layer. That is a more important role in your network. Take a look. Here is a list of features that Cisco listed for you, and of course it will detect any loops in your network, and it will run routing protocols here. It will make some decisions as well. It will load balance. Okay, that's the main role of the distribution layer. The last one is the core layer. The core layer is, if you want to summarize this layer in one sentence, high-speed connectivity. You want to exchange information as fast as possible. You don't want to make any decisions here. Take a look. You will not find a point saying, well, let's see if we can get here. Let's see if not really. The core layer is designed to send your data as fast as possible. This is for big networks. In many cases, we don't need a core and distribution. We don't need these layers. We can do something that is called a collapsed design. It means that we will combine the core and distribution layers. Why? Well, in many cases you don't need a separate layer like the core layer, and it's okay. You can combine these two guys together. It means this is your access layer and this is your core and distribution. Let's take a look at a small office, home office network now. Small office, home office network. You will see that in many different places. That is a very popular design. Again, the star topology. You have a switch and all devices connected to it. Let's try and analyze what we can see in the picture. First of all, we can see a switch. This switch allows all our devices to talk to each other. Another very important device is a firewall. Sometimes you will see a firewall and a router in one box. That's absolutely fine for a small office, home office environment. A very popular solution. You can combine these two features. You can even have a router, a firewall, and an access point in one box. It means that you will combine these three devices in one box. You put it here. If I show you this picture again, you will see most small office, home office routers will have an access point and a switch. We'll talk about it in a few minutes. a wireless access point. Of course, it allows our laptops to connect phones to the network. Here, end devices, wired connections, laptops, printers, scanners, phones, and so on. This router is connected to the internet. It means here is your ISP, Internet Service Provider. That is for a small office. Imagine I promised I would show you a building with 3 floors, 0, 1, 2, and 3. You would design your network, for instance, like that. Let's put 2 core switches here. That's your core. Then you go for 2 ISPs. You connect it like that and like that. You connect 2 core switches using 2 links. Then on each floor you're going to put an access layer switch. Do you remember what an access layer switch is? Very good. We connect end devices to it. Access layer switch. And you will connect it like that. This guy here, this guy here, this guy here, this guy here, here and here. Do you agree with me that in a design like that, you will not find a single point of failure? The idea is that if a single device fails or a single cable fails, the whole network goes down. That's not the case here. Let's say, let me change the color. Let's say that this ISP, that is ISP1, this is ISP2. We have 2 internet providers. If ISP1 dies, then everybody will say, okay, we should start using ISP2. What will happen if our core switch 1 fails? No problem, we'll start using this one. What will happen if this link goes down? This guy will say, not a problem, I can use this path. What we can find in our networks. First of all, a very popular device is, of course, an all-in-one device, a router. This is a router, a switch, and an access point. Not bad for £20, isn't it? By the way, this is the most popular router that Linksys have ever made. We'll talk about it. I will show you how we can set up a router like that. Why is it a good idea to have a device like that? Well, first of all, it is much cheaper. You don't have a lot of space. And most home networks look like that. You will have a single device. Do you agree with me? Yeah, if not, go and check what you have in your network. In most cases, you will have one device. You connect to the internet using a single device. You have a laptop, you have a PC, printer, they can talk to each other, and of course all these devices can browse the internet. That's a router, switch, and an access point. If we don't have enough ports, and that can happen, I'll show you a zoomed in version of this device in a sec. You can see in most cases you will find 4 ports. It means we can connect 4 devices to a router like that. Oops, let me just fix that. Yeah, 1, 2, 3, 4. That's it. And that's 5. Yeah, that's 4. If that's not enough, what you can do, you can take a cable, connect it like that here, and then you are going to get 1, 2, 3, 4, 5, 6, 7 additional ports. You have to sacrifice 1 port because it has to go to your existing router. 7 ports, more than enough even for a medium-sized company when you have printers, laptops, PCs, scanners, and so on. You can buy a device like that from almost all vendors like Netgear, HP, Linksys, D-Link, and so on. Let's try and zoom in and see what's inside. That is, I think, a Linksys router. It doesn't really matter, most of them look the same, have the same ports. I don't know why, I really don't like when they do that. Yellow should be LAN. I really hate when they do that. It's like breaking the rules. Yellow is your local area network. I know a lot of companies, I don't know why, they say, why not? Let's break the rules. Let's make it yellow. It's stupid. Anyway, we have 4 ports, 1, 2, 3, 4, that we can connect our end devices, PCs, laptops, printers. This link goes to your ISP, Internet Service Provider. Literally, you grab a cable and you connect it to sometimes a device that your ISP provided or a socket. That's how you connect a router to the internet. Again, if you don't have enough ports, you can say, okay, then I will take port number 4 and buy a switch. And the switch will allow me to connect additional devices. What you have to bear in mind is that this is a single link. Sometimes it can be a gigabit link. Gigabit is fast. However, in this case, it means that if you want to send a message from this PC to that PC here, and at the same time from this guy to that guy, that might be a problem. It's a single link. It's not like sending a message directly to these two guys. You have to be careful. It's not the most powerful switch in the world. If you try and send a message from here to here, from here to here, and a backup from here to here, from here. Okay, this thing can just die. Let's summarize then. We talked about the network topologies, network components, and I showed you some network devices that we can use in our networks. Thank you very much.